See, this is the continuation of the previous session where we are revising all the things, summarizing whatever we have learned for internal exam 1 preparation, which is starting from 20th of this month, right? You people have received the notice about that, right? Yesterday we have gone through the process, okay, management, and in fact, session we did not. Due to technical problem, we did not conduct the session yesterday, and today we'll continue that. Then we'll get into the lab-related revision, right? So let's look into the memory. Okay, memory management. This is one of the services provided by operating system, right? So what all the things that we need to look into, because this is an introductory course, and you will be having a detailed course in the next semester. So when we went for the memory management, right, we recollected the process, because when process, I mean program in execution is called a process. The process is stored in the memory, right, and then swap in, swap out, how exactly the memory management takes place for all the things. For that, this flashback is required, right? We have gone through in the last class about the kernel program, then process, system calls. Then this is the important thing which, okay, you need to look into that, right? Which you need to look into that, right? When a program is loaded into the memory, right, or the process is running, C programming layout that we are seeing. All command line argument, they stay at the top of this high address. Stack is here. Stack grows like this. Then you have something called a heap and all. Then you have initialized data, and the machine code which will be executed. This is the layout of the entire program, right? And please remember, the entire program is not loaded into the memory at one shot, right? How, where, and all. Okay, would like to see in this semester and next semester, right? Here is a program segment, right, wherein different variables, whatever you declare, where exactly they can get into, we are seeing it. Initialized data, uninitialized data, then all automatic variables they store in the stack. Then you have in a double quote, whatever you write, they're all initialized read-only data. Then you have a dynamic variables, okay. In pointer, you will study about that pointer. We can allocate the memory, okay, malloc, alloc. During runtime, we can allocate the memory, request the system, allocate this much of memory. One of the example is here, malloc, right? So you will study that soon, right? Otherwise, I will cover it. It's a part of the C program. Malloc, right? You allocate the memory. Okay, that will go. That will, as a dynamic variable, it will go into the heap, right? This is the kind of things that we have seen it, right? Manoj, Shimarashmi, Akshata, is it okay?
Yes, sir.
Oh, that's good, right? That's good. Then who will load program into the memory? That's what is, and who will execute, right? And we have seen exec system call, which will, okay, ensure that the program which is there in the disk, that is loaded, the executable image is loaded into the memory, and it will call the C startup routine. That in turn call the main function and all your functions and all, and you make an exit. This is how we referred it as a part of the process management, right? Then quickly we'll move. This is not required, right? Now look at that. When a process is running, when a program is running, we call a process. Process details are stored. This also we have seen in the last class. Okay, they are stored in the memory, right? It is required, because when a process completes its time slot and it is to be swapped out, okay, this information is stored in the memory. Again, when it gets a turn and get inside for the CPU allocation and all, okay, this particular information is being used, and it will start from the point where it has stopped before, right? For that, okay, this runtime information about the process is being stored in the memory, and we call it as a process control block or the task control block, right? Please look into that. Okay, you will be having a sure reference of this one in the examination. right? Then other things we don't want to get into. Now directly we'll get into the little bit of memory management we'll touch upon, because in a great length you will be studying in the next semester. So look at that. Programs must be brought from the disk into the memory and placed within the process for it to be run. Okay, it is brought into the memory in the sense, right? It is the executable is available in the hard disk, right? That's what you write dot forward slash a dot out. You do what is that, right? You are executing that particular a dot out exec. The exec will ensure that that image is brought into the memory and it is okay loaded in the memory which you already seen it, right? That's the second point is main memory and registers are the only storage for the CPU and can be accessed directly by the CPU, right? The main memory and register, these are the only two things which CPU can access. Memory, that's why you have to bring whatever that is there in the hard disk back into the okay main memory. Who is to do it, right? A memory management service of an operating system will do, right? Memory unit only sees a stream of addresses and read requests or addresses plus data and write requests. That's all. Whether it is a C program or Python program or C++ program, it doesn't matter for that. So memory management is address and instruction, what instruction is there. That's all, right? This is what is an important thing. A register access in one CPU clock, right? That's why whenever a variable is stored in a register, you can quickly access that one. But that CPU clock in the sense a time unit, right? Within one time unit, you can access the register, which are very close to a CPU, got it? But whereas okay, memory access, it takes some more clock, CPU clock, so it takes more time. And this can be compared with whatever that is stored in your mind, brain, right? Right, that you can access immediately. But whatever that is there in your bag, you have to open the bag, right? Open the notebook and then read it. So it will take some more clock time, right? This is what is being said here. Main memory can take many cycles, right? But accessing what is stored in your bag takes many cycles, time, more seconds, right? Then cache sits between the main memory and CPU. Why? Because right, main memory accessing is slow. It takes more clock. CPU registers are CPU is very fast, right? So when you cache and keep it ready, for example, your father says, okay, from that go to kitchen and get from this box get it, right? And you are sure that one is going to ask for the next box, whatever that is there. So what you do is when you are giving your father the first box, second, and when your father is working on that, the second box you prefetch it, and keep with you, right? Then when your father asks, give me the next box, it is readily available, right? When your father is doing something, computing on the first data you have supplied, the second set of data you fetch it, keep with you. When your father asks, give me next one, it is readily available there, immediately you will, thereby you can okay, improve the performance of the CPU utilization, right? And that is the purpose of the cache. And your father will give you, say that, take this box, it is there with you, you don't keep it in the kitchen. And again says that one, get me, okay, get me the first box, right? You don't go to the kitchen because it is already there with you, right? That is called caching. You store it with you, and whenever CPU wanted, your father is a CPU here, immediately you give it. Thereby, additional cycles of memory access required to access the main memory, you can avoid it. Okay, that is the purpose of cache memory. You may get a question, what is cache memory? Why it is required? Why it is required? Could be for 1 mark, right? Then protection of memory required to ensure the correct operation. For example, in the I'll tell you about that. Now look into that, right? The process, okay, whatever you are saying, the first block, okay, consider that there is a program written by Manoj and is executing. And process second process here. Let me mark here and tell you that will be better. Yeah. See here, this is related to Manoj. This is related to Himarashmi. This is related to Akshata, right? So Akshata is running Python program. Himarashmi is running a C program, and Manoj is running a Pascal program, right? So there should not be mix-up of this. There should not be any mix-up of this. Hope you understand that, right? So how do you ensure? The operating system will ensure. How? Right? See here, for Himarashmi, it knows that when it starts from 300040 address and it goes up to this, right? And any address, the program written by Himarashmi, this is the program written by Himarashmi, they generate address, instruction address, right? It will ensure that it is greater or equal to this particular thing, 300040, and less or equal to, okay, 42, okay, 0940, right? This, are you getting this? So within this, it will ensure that within this particular block, you are being executed, so that one program is not being mixed up with the other program. This is a kind of a protection. How do you ensure that? A pair of base and limit register, right? Even for your house, boundary, you put a fence. Similarly, you have got a fence here. What is that? A base register and a limit register, right? And base register, you add, okay, some offset, we call as an offset, right? So you will become a first instruction, second instruction, third instruction. When I say third, it is a 30040 plus 3. When I say fourth memory location, 300040 plus 4. That's how it will ensure, right? So are you okay with that?
Yes, sir.
And it is being referred as a logical address. When I say fourth instruction, right? What is the fourth instruction? The address is 4. It means that base address plus this 4. Correct? So 4, 5, 6, 7, 8, they are called logical address. Right? 30040, 1 minute. 30004, 4 is a physical address. How do you get it? Base register this plus 4 will become this, right? This, okay, 1 minute, I'll change the color of my pen here. Wait for that. This is what we call as a physical address, and this is what we call as logical address, right? And this is what we call as a base address. Okay, probably in your computer organization, your concerned course teacher might have introduced something about this. Himarashmi, am I right?
Yes, sir.
Okay, now you may get a question. Okay, how do multiple programs are loaded in the memory and memory management activities being done? Explain, right? You have to explain with such a diagram, right? And maybe use the base and limit register and speak about that. Are you okay with this? Are you okay with this?
Yes, sir.
That's good, right? It is available in the textbook also, or wherever possible, you can take a screenshot of this also, right? Right. That's what we were talking all about that. Anything clarity that is required here? List and explain the memory management activity of an operating system. So you can write few lines and you can explain with this such a diagram. Are you clear? So to elaborate this, I'll take you another thing. Now look at that. What happens? This I told you. 1 minute. I'll take a pen again. Right. See here. I told you the logical address is 4. This 4, for this logical address, you add base address. What is the base address? It is a 300, whatever that is there, and you get the physical address. You can very well explain with this diagram. Now look at that. In this case, right, the logical address generated is 4 here. The logical address is 4 here. Is it greater or equal to base address. For simplicity, I'll take a base address is 300, not 30040 something like that, bigger one, so that I can write in short here, right? Is it greater or equal to? I mean, there's the CPU, whatever the address it generates, right? Okay, it takes this one 300, okay, 3000, 300 here, 300 plus 4, it adds it, right? Right, it becomes 304, right? This is this address 304 greater or equal to base address? Yes. Right. Is it right less or equal to base address plus limit? Because you are supposed to work within a particular area only. Assume that this is 300, right? Then the limit is 100 only, right? That means 300 plus 100, that is equal to 400. Okay, 300 to 400 is a space that is given to you. So base plus limit, whatever the limit is there, is your address 304, whatever you have generated, is it less than 300 plus 100, that is 400? Yes. Then you are somewhere here within the your boundary, right? Then you are permitted to access your address. Otherwise, a trap, an interrupt will be generated to operating system, and it will give an error, addressing error. You are accessing illegal memory which is not allocated to you, right? So this is what is called hardware address protection, right? You can very well right, look into this, explain the memory management service provided by an operating system in terms of, right, the protection, how it protects one user from the another user. Are you getting it? Right? So very well you can explain about these theoretical things. You can write this diagram, and very well you can explain with this particular diagram. Himarashmi, am I right?
Yes, sir.
Right. And we are limiting our memory management activity only to this, not beyond this. Right? Or sometimes, I mean, some explanation further, I'll add it to this. A program resides on a disk as a binary executable file. A dot out. Am I right? Himarashmi, A dot
Yes, sir.
out. Right. The program must be brought into the memory. How do you bring it? How do you bring it? EXEC. Am I right? I want a response from Manoj and
Yes, sir.
Himarashmi. Yeah.
Yes,
Does it?
sir.
Right. Immediately I ask question, you respond. The process may be moved between the disk and memory during its execution. Why? Swap in, swap out. Because CPU is not allocated to you all the time. It will allocate, it will run for 500 millisecond. Then from Himarashmi, it will move to Manoj. Manoj 500 second, 500 millisecond. Then it will move to Akshata. Then again, it will come back to the Himarashmi, so that you feel that, okay, all are being given attention by the CPU, right? This is called multi, okay, programming environment. Is it okay?
Yes, sir.
Okay, the process on the disk that are waiting to be brought into the memory for execution, okay, from the input queue. Okay, got it? Input queue is there, from that it will bring, right? A normal procedure is to select one of the process, right, in the input queue and load that process into the memory. Loading that in the memory layout, you know about that. Are you clear? Right. Okay. As the process is executed, tell me.
Sir,
Uh, hmm.
sir, is every program brought into the memory by EXEC, sir?
Okay, initially it is brought admitted into the queue. Then within a queue, right, bringing is not done by EXEC. From the hard disk, EXEC will bring once, right? It. Then within that, whatever there that is there in the queue, the internal service of an operating system will pick that one. Swap in, swap out is being done by operating system services internal. Got it? Uh, in a
Yes,
hos-
sir.
in a hospital, we get admitted. We get admit card. EXCC will do. Within that, you go to doctor. Doctor will say go to X-ray and again come back. Right? Again come back. Who will do that? It is the internal. Okay, office managers will do that. Are you getting it? Hmm?
Yes, sir.
Right. As the process is executed, it accesses the instruction and data from the memory. Where instruction is there, where data is there, memory layout, you have seen it. Okay? Okay?
Yes,
Eventually, the process terminates and its memory space is declared unavailable. In the sense, whatever the memory you are used here, right, allocated to Imarashmi here, second one, that will be released. It is freely available. So that it will be allocated to other program. Is that clear?
yes, sir.
Right? That's what happens right here. Got it? I don't want to take further because that you'll be studying everything in your next semester, right? Just to summarize like a little bit ahead of time, a little bit correlate. I'll be using this. You got a source program. Imarashmi, tell me, is it okay? This is known to you. Source code .c. Okay.
Yes, sir.
You compile okay the code, compile or assemble, compile, right? Okay.
Yes, sir.
Then the object module is generated. All okay libraries, everything. You will 1 minute. All libraries, everything. Okay, you will link that one. Okay, loadable module is ready. A dot out, right? A dot out, that is available. It is up to this. You people know. Then okay, 1 minute. 1 minute. I'll use change the color. Then there's a concept called loader. There's a concept called loader, right? Which will load, okay, your loadable module into the memory. In memory, binary memory image is being right put into the memory. How do it is put into memory? EXEC, right? And it will execute that. Is it okay?
Yes, sir.
Right. This part, the one which you need to visualize. You cannot ask me, show that physically where, how it is happening. Sometimes conceptually you need to visualize and understand it. Right? For that reason, again, we have put EXEC system call use in the exercise of laboratory. Is that clear?
Yes, sir.
Hmm. Right. That's good. That's good. Right. Then uh, this under this concept I write. Okay, I told you. Right. Just now I told you. Let me recollect once again. Uh, right. You have got your logical address. Right. I told you an example of a logical address is 4. Then you have got a base address. Say I gave an example of 300, right here. Then it gets added. It becomes a 304. 304 is your physical address. Okay. We call it as a logical address. My instruction is number serial number 4. But actually in the memory it is a 304 because where exactly it is okay memory is allocated to you we don't know, right? Is that clear? Is that clear?
Yes, sir.
Okay, that's good. Then what else is required for you? Yeah, look into other aspect. Visually you can see this, right? In the memory, operating system will be loaded during the boot time. I told you about that yesterday, right? Then this is the entire user space. It is partitioned into different things and all that we'll see how exactly it is being done. This is your okay backing store hard disk, right? process P1, A dot out, right, or another executable program, okay, they are, this is taken inside and this is taken out. We call it the swap in and swap out. Got it? Right? Is that clear? The term swap in and swap out?
Yes, sir.
Okay, that's good. Anybody, any student, if they have any thing to be asked, they can unmute and start talking to me, but that will be controlled by Manoj and Himarashmi. I think that's enough. Remaining all, we will see it in next semester. Next semester we will see it, right? Other things are not required. Only up to this, right? A schematic view of swapping. What is the swapping? Why this is required? Then you have concept of a logical address and physical address. Then you have the overall concept of the multiple steps used in executing a user program. Then there's how exactly what kind of hardware mechanism available for address protection. Whatever the address you generate, it should belong to you, right? The hardware address protection mechanism given available in memory management, explain with a neat diagram, right? Yes. The use of base and limit register in managing and in providing a memory management service in multi-programming environment. Please look into that. The base and limit register usage, explain the base and limit register usage in managing user programs in multi-programming environment, right? So that is enough. Okay, now as far as the third semester is concerned, right? Is that clear? Any question at this stage? Himarashmi, any question at this stage?
No questions, sir.
Right. So we are in the process of preparing for the examination. Please understand that. Right? Is that clear? So introduction to operating system, computer system, we have seen it. Organization, architecture, little bit. Operating system structure, operating system operations, introduction to process management, memory management, right? Right? Storage and all, we gave an example of directory structure and all, that is enough. Protection and security, we have seen it, right? Distributed system is too okay early at this stage, correct? Then operating system services, system calls we have seen, system programs, compiler is a one system program, operating system linker, right? Editors, right? Operating system design, right? In short, it is not in length, right? So please recollect. Let me refer to one important thing which we referred it in our process last time. This is a very important thing. Okay, what are the design principles of an operating system? Design principles, please look into that. All this I'm referring. Design principles, when we look into, just a minute, just a minute. All these things are not required. Protection mechanisms, you can explain very well, like system calls. Yes. Right. Yeah, look into that. Operating system design and implementation. Now, I told in the last class that policy and mechanisms, these separations will enable okay, better flexibility and portability, right? Policy, what will be done? right? Mechanism, how to do it. Policy, I gave an example, printf, I want to print on a screen. That's all, it's a policy. Mechanism, how do I implement it? How do I do it? That is, many times I told you, system calls are, right, vendor depend, the implementation dependent, right? So you get a service, printf, but how internally it is being implemented, there may be variations in different implementation. It need not be same. Correct. So the basic, okay, principle, design principle, okay, there are two. One is you isolate the mechanisms from the policy. What I mean is, right, policy here is printing on the screen is a policy, but it's the implementation you isolate it. Okay, there is a separation between these two. Got it? So that whenever you want to maintain or do a portability, right? To explain to you, let me use this screen and then tell, right? See, for example, I'll give one service here. Service S. It is being implemented using, right, implementable aspect of that in Kulkarni operating system, because I'm handling implementation based service, right? Now what I want to do is I want this to be ported to other machine. So what happens is whatever the yes I'm writing here, that will remain same, so that it will ease my work. I need not have to repeat this. But whereas, okay, its implementation may be different, so different kind of implementation, okay, is dash, this particular thing only I will focus on that. So the code writing for whatever the mechanism is there, that much part I will be saving it, right? So this principle of separating policy from mechanism will help in portability, right? When you port the operating system from one machine to other type of machine, right, writing the code from the scratch is not required. Only machine dependent aspect. What is the machine dependent aspect? This is machine mechanisms are a machine dependent aspect that you can write, and your entire service is available on new machine in the sense new architecture. It is not that my laptop to your laptop. Okay, both are same Intel, so and so, so and so. Okay, they are not called different machine. When I say machine, different machine is a different architecture, right? Different processor. Is that okay, Himarashmi?
Yes, sir.
Okay, this is only one thing. Don't get carried away by that. Saying that one sentence is there in a syllabus. Okay, what all things we need to learn, right? Okay, it's not like that, right? Then, then what? Operating system structure, virtual machine, okay, system boot that we are seeing, right? Grub, yesterday we are talking about that. From EPROM, what is stored, how initialization takes place, right? Unix system structure, commands, few commands we have gone through, right? Cat, ls minus l, right? Cp, mv, okay? Then ps, right? You will study different things as and when you use it. Change mode, right? Then file directories we operated, password protection, VI editor you are working with that, right? Daemon process, right? Before telling daemon process, let me tell you about system calls. We are seeing different system calls related to process, files, and directories. We have done it through programming, right? Now, what is the daemon process? Now, let me give an example of human body and then take into uh, the computer system, right? Now, look at the human body, okay? We say for the human body, panchaprana. You know about that? It is not a Kannada word, panchaprana. When you see the sweet, you people say that it is my panchaprana. That is not panchaprana we are talking. Unknowingly, we talk that. Panchaprana, breathing, blood circulation, digestion, and all waste material, okay, throwing it out right from the body, they all happens for you process, right? And that's what we refer it as a God, right? God is there inside you. What is that? This panchaprana, this when the moment the panchaprana they go out of that, the body is dead. Got it? And these process, right, they continuously happen in the body. You cannot control that. You cannot stop it. You cannot delay it. Right? They happen. The moment you you take a birth, okay, they will be there all the time, round the clock. Now look at that. Some application program you are running. You are sitting now listening to me. There is application program. 10 o'clock it get terminated. But in your body, breathing will be there all the time. So like that, in operating system, when you boot, like there are many process that is available until you shut down. They are all called daemon process. They run all the time. Got it? They cannot be stopped. The moment you stop, certain services fail. Got it? And because of the collection of daemon process running, you find that an operating system. What is operating system? Collection of several daemon process. A collection of breathing, blood circulation, digestion, right? All that makes you, okay, as a service, as an entity available in your family. You are alive, right? That's, and that is being called daemon process, right? Yesterday we were talking all about, right? When you look at the parent ID, right? Parent ID of any process, you get a shell. For a shell, who is a parent? There is something called init process. Init is a parent for everyone, right? Okay, you can check that also, right? I'll show you 1 minute. See here. 1 minute, see it here. Oh, it's taking time. One. Until that, any question here? Until that, any question? Until system comes up, any question? Himarashmi?
Question, sir.
This is the portion for IA1, right? So, and you know the textbook, please go through the textbook, right? Not the first one, second one you have to get into, right? Correct. Galvin book. First one book is meant for chapter number 4 and 5, which we will start 3, 4, 5. We will start immediately after the IA1. Right? I'm not getting okay into chapter number 3 right now. Otherwise, would have gone through. I'm simply revising it. And I told you, except LS Manasial implementation, rest all programs are there for IA1. Your direct listing, your displaying file attributes, fork v4, exec, right? Command line arguments, right? Whatever that is there, everything is there. And you forget about the other division, what happens there? Likely that one we will be having separate question paper for them also, right? Got it. What is happening is in my division, introduction to Unix operating system for you is going well, but data structure is the concerned teacher is on leave. In B division, data structure is going well, introduction to Unix operating system is not being done. So for both of you, okay, we'll be having a separate examination. Wait for official notification from my side, right? Don't take it right now as it is. We'll officially inform you and concerned teacher will inform. Concerned teacher will inform, right? So session is getting closed now, and after 5 minutes break, okay, now it is 8:40, 8:42, right? Sharp 9 o'clock join again. We'll begin with the laboratory exercise review. If you have any doubt, okay, would like to address that, right? So 10 minutes break, 10 to 15 minutes break, and you will be rejoining at 9 o'clock sharp. It is 8:43 in my system. Sharp 9 o'clock, please join, all of you. Thank you. Bye. Himarashmi, Manoj, shall I close this?
Yes, sir.
Right?
Yes, sir.
1 minute. I'll stop sharing. 1 minute. As many as, okay, 40 to 37 people. Now it is 37. Earlier it was 40. Right? We wanted all the people to join for this revision. Okay, ensure that things will go good. Okay, I'll stop now. End the meeting. Join sharp at 9 o'clock.